Hi, ladies and gentlemen. I am going to be talking to you guys today about how we can describe motion. There are 4 key points when we are describing motion. Okay, first of all, our descriptions, are going to depend on a reference point. Okay, when we describe the position, we want to know how can we do that in 2 dimensions. And then lastly, we want to know what's the difference between distance and displacement. Okay, and if we can do those things, then maybe we can describe the motion of an object, and then we can use that for continuing our studies of motion, looking at speed and velocity. Okay, so when we look at motion, okay, there's all kinds of amazing motions that happen, like we see here with this surfer. Okay, so describing position. In order to describe position, we need a reference point to start from. So maybe you're describing how we get to your house from Drake Middle School. Okay, so Drake Middle School is your point of reference or your reference point. And then how do we get to your house from Drake Middle School? Okay, so you would have to give us a complete description of the position, okay, of your house. And in order to do that, we would have to know how far and what direction, okay, we are going from Drake Middle School. Okay, and lots of times, like that might mean going north for a little while, and then possibly going east, and then going north again. Okay, so we're describing distance and direction from the reference point, which might be Drake Middle School for this example. Okay, it's important to find a reference point that's something that's easy to find, okay, so that people know what you're talking about. Okay, and then if a reference point changes, so does the description of the objects, how to get to that object, right? So if instead of describing how to get to your house from Drake, you were describing how to get to your house from the Apex Center, okay, or Stanger Soccer Field, you would have to change your description, okay, to match that new reference point. Okay, if you change the reference point, it doesn't change the actual position of the object, okay, which makes sense, right? Just because you're explaining how to get to your house from Stanger doesn't actually change where your house is located. It just changes how we get there. Okay, and lots of times our frame of reference, our reference point, can make things look pretty interesting, right? So in this frame of reference, it looks like these individuals are actually able to hold this car up in their hands. Okay, and we know that's just based on the frame of reference. That car isn't really being held up by those individuals. Okay, when you describe an object's position, you compare the location to a reference direction. So you can either go positive or negative. So if I'm looking at this picture, this plane is flying, okay, to the right, and the individual is throwing the ball to the left, and the car is moving to the left. So I would say maybe that this plane is traveling in the positive direction, and the ball and the truck are moving in the negative direction. They're opposite of each other. Okay. Then when we're describing the position of something, okay, if we're describing it in 2 dimensions, we're going to use 2 directions. Okay, examples would be north and east, right and forward. Okay, so to find a position in 2 dimensions, you choose a reference point and then specify reference directions, right? So when we talk about like the location of Denver, Colorado, right, these are the coordinates for Denver. Okay, so it's 39 degrees, 44 minutes north, 104 degrees, 59 minutes west. Okay, so those coordinates are relative to a specific reference point. Okay, and we determine the distance along each reference direction. Okay, so that's how we are going to figure out how far we are from that reference point. So next, we've got describing changes in position. Okay, when we describe changes in position, okay, motion is the process of changing position. So if we see this guy on his skateboard here, okay, if he's looking at the ball, it looks like the ball is going straight up and down. Okay, and so when he looks at that, okay, it looks straight up and down. But if I'm watching him, it looks like the ball is actually traveling in this curved arc. Okay, and that's because the frame of reference that the individual is looking at is 2 different frames of reference, right? Either from an onlooker or from the actual individual. Okay, so it is possible to move with regard to one reference point. Okay, so it looks like, okay, the ball is traveling in this arc, in one reference point and staying motionless with regard to another reference point. Okay, so again, I'm sitting here in a chair and I'm just sitting here. Okay, but am I really motionless? Well, relative to the chair, I am. Okay, but I am actually moving because the earth is moving. Okay, so if I look at a different reference point, okay, my motion can change. So when we talk about describing, okay, movement or motion, we want to think about two key terms, distance and displacement. Distance is the length of the path the object moves along, right? So here's my little bee. He's buzzing, right? He's buzzing all over the place, right? So he traveled a great distance, okay, but his displacement, okay, was significantly shorter. So displacement is the actual difference between the initial and final position. Okay, so they are not always the same, but they can be. And the time when it would be the actual same number, the distance and displacement, would be if this bee had only traveled in one direction, right? If he had gone directly to the right, okay, then his distance and displacement would be exactly the same. But because he went a little up, a little down, a little around, right? He went a bunch of different directions, hey, his distance and displacement are not equal. So here are just a couple examples when we're looking at distance. Okay, distance is how far an object travels. It does not depend on direction. Okay, so we've got our little ant, and our ant crawls along the ruler, right? And this ant moves along, and he goes 1, 2, 3 centimeters, right? Okay, so that's how far this little ant traveled. Okay, so that's his distance. Okay, and whenever we're describing something, we're going to use the units, right? So this is 3 centimeters, not just 3. Okay, so distance does not depend on direction. Okay, so if I'm looking at this little ant, right, and he starts at the 3 and goes back to the 0, okay, how far has he traveled? Okay, same distance, right? So he's gone 3 centimeters as well. Okay, so the direction does not change the answer. Okay, distance does not depend on direction. Let's follow the little ant again. Okay, so my ant went, and then he went, okay, so based on that, okay, what distance did the ant walk this time? Okay, so if we take the distance he traveled this way, add the distance he traveled that way, we get, okay, 7 centimeters, right? Because he went 5, 6, 7 till we get to the end of the arrow. Okay, distance versus displacement. An example of distance, the ant walks 3 centimeters. Displacement, the ant walked 3 centimeters east. Okay, so when we talk about displacement, direction matters. Okay, an object's distance traveled and its displacement are not always the same. So again, here's my little ant. Okay, and you guys will see in terms of displacement, there's a positive and a negative direction. Okay, so let's figure out this ant's displacement. Okay, his distance he traveled was 3 centimeters. Okay, what was his displacement? Displacement is positive 3 centimeters, right? So he's moving 3. You could also say like 3 centimeters to the right. Okay, positive gives the ant a direction. Okay, here's my ant again. Okay, let's find the ant's displacement again. Okay, displacement does have direction, so now this ant traveled the same distance, 3 centimeters, but the displacement was negative 3 centimeters or 3 centimeters to the left. Okay, find the distance and displacement of the ant. Okay, we remember from the last time the distance this little ant went was 7 centimeters. What's the ant's displacement? Okay, well, the displacement, okay, is going to be from the starting point to where the ant ends up, okay, the ending point. So that means the displacement is positive 3 centimeters or 3 centimeters to the right, because he started at 0 and he ended up at 3. Okay, distance and displacement. An athlete runs around a track that's 100 meters long 3 times and then stops. What's the athlete's distance and displacement? Okay, he went around 3 times. So that distance, 100, 200, 300. Okay, the distance is 300 meters. Displacement is 0. Okay, so the ant ended up at the same place that he started, or sorry, the athlete ended up at the same place that he started. Okay, and so when we talk about the reason why, okay, because displacement has direction, and in this case, the individual ended up at the exact same place that he started. Okay, so when we talk about distance and displacement, here's our start point. Okay, here's the end point. Okay, which line represents distance? Okay, the white line or the yellow line? Okay, so distance, okay, would be the white line. Displacement, start directly to the end, and it's a straight line from the starting point to the ending point. That's displacement. Okay, so you drive the path and your odometer goes up by 8 miles, your distance. Hey, your displacement is the shorter directed distance from the start to the stop. Hey, what if you drove in a circle, right? If you just went around in a circle, right, your distance would continue going up. Hey, but every time you went back to that starting point, your displacement would go to 0. All right, ladies and gentlemen, that's it for distance and displacement today. So I hope that helps you guys get an understanding of the difference between distance and displacement, how we can describe motion, how we can describe motion in 2 dimensions. So using like north and south or right and left. Okay, and sorry, not north and south, like north and west and right and up and down. Okay, so I hope that helps, and I hope you guys have a great day. Bye.